start with the introduction. What is amination? Amination is a pivotal reaction in organic chemistry where an amine group, NH2, is introduced into a molecule to form amines. Amination significantly impact the pharmaceutical industry. These reactions are pivotal in the synthesis of numerous medicinal compounds, enabling the development of drugs with enhanced therapeutic properties and improved bioavailability. Okay, first for the application, our group decided to choose paracetamol, which is an analgesic and antipyretic drug. So paracetamol, also known by its chemical name acetaminophen, is one of the most widely used medications globally, renowned for its efficiency as an analgesic, which is pain reliever, and antipyretic as fever reducer. Okay, for organic compound involved, firstly, we have the starting material, which is phenol in general form, and then we have p-aminophenol, acetic anhydride, and acetic acid that involve in acetylation reaction mechanism, and then the last but not least, the final product itself, which is paracetamol.
Paracetamol is made by reacting 4-aminophenol with ethanol anhydrate, more commonly called acetic anhydride. This reaction forms an amide bond and ethanol acid as a byproduct. When the reaction is complete, the paracetamol is then isolated and purified. The synthesis of paracetamol can be broken down into three parts. Part 1 mix the reactants together to form paracetamol. Part 2 isolate group paracetamol from the ethanol acid and unreacted starting materials. And the last part is purify paracetamol by recrystallization. This is how the mechanism reaction occur, and the last product we will get ethanol anhydride and also aminophenol. The lone pair of electrons on the amine of 4-aminophenol attacks the CO bond of acetic anhydride, causing it to break. And then nitrogen has a positive charge but regains electrons by losing a proton. The negative charge on the oxygen comes back in the reform the CO bond. That causes the other CO bond to break. The result is an amide bond formation and carboxylic acid byproduct.
Next is application of sulfamethoxazole. What is sulfamethoxazole? Sulfamethoxazole is an antibiotic that belongs to the sulfonamide class. It is commonly used in combination with trimethoprim, another antibiotic, in a formulation known as cotrimoxazole, or TMP SMX trimethoprim sulfamethoxazole. What is the uses of sulfamethoxazole? Sulfamethoxazole is commonly prescribed to treat and prevent UTIs, which is urinary tract infections. Next, it is also can be used to treat bronchitis, sinusitis, and other respiratory infections. Moreover, it is also effective against certain types of otitis media, middle ear infections. Last but not least, it can treat certain types of gastrointestinal infections like shigellosis. Next, organic compound that involved in the sulfamethoxazole is p-acetamidobenzene sulfonyl chloride. Next, 3-amino-5-methyloxazole. Next, 3-acetylsulfonamide, 5-methylisazole, and the last one is sulfamethoxazole.
The mechanism of sulfamethoxazole involves p-acetamidobenzene sulfonyl chloride and 3-amino-5-methyloxazole. The first reaction is the nucleophilic attack. The lone pair of electrons on the nitrogen atom of the amine group in 3-amino-5-methyloxazole act as a nucleophile. It attacks the sulfur atom in p-acetamidobenzene sulfonyl chloride. Sulfur acts as a electrophilic center due to the high positive charge density. When the nucleophilic attack occurs, the electron share between sulfur and chlorine atom will shift further towards the chlorine due to chlorine is more significantly electronegative than sulfur, means that chlorine has a much stronger attraction for electron compared to sulfur. The hydroxide ion from sodium hydroxide act as a nucleophile and attack the carbon atom that attached to the nitrogen atom. The electron share between carbon and nitrogen atom will shift towards the nitrogen atom because it is more electronegative than carbon atom. A water molecule acts as a Bronsted lauric acid and donated a proton, which is a H plus, to the nitrogen atom that lost its bond with the carbon atom. So this proton transfer regenerates the aromatic amine group in the sulfamethoxazole. The deprotonated water molecule loses its remaining proton and becomes a hydroxide ion. So the final product will be sulfamethoxazole.
Amination reactions play a crucial role in the synthesis of various pharmaceutical compounds, including antibacterial agents, such as sulfamethoxazole and pain relievers like paracetamol. In the synthesis of sulfamethoxazole, the amination reaction is a key step in the formation of the final product, which is an important antibacterial agent used to treat a range of bacterial infections. Similarly, in the synthesis of paracetamol, the amination reaction is involved in the formation of the intermediate compound, which is then converted to the final product. In conclusion, amination reactions are a vital component of pharmaceutical synthesis, and their importance will continue to grow as the demand for new and innovative drugs increases.